Hey kids, let's do a little review. So this handout is on our page and it is the back of Derivative Practice 1. The front side of it has 11 problems, right? Just a whole bunch of more derivative problems to practice. And then the back side has this table on it. And I want to do this with you because this is definitely an AP style question. They like to do these. The actual computational math is trivial, but they're going to test you on your knowledge of product rule, quotient rule, chain rule, okay, using values from this table. So notice the first thing I did when I scanned this is I looked to see what rules I needed to put into play. So this was not the product rule or the chain rule or the quotient rule, right? This was the derivative of a difference, right? The derivative of a difference is the difference of the derivatives. Now I didn't copy over the directions, or I didn't capture the directions here. So the direction said this was, given these two functions, f and g, find the following derivatives. So this says f of x minus 2 times g of x. What they're asking then for is f prime of x minus 2 times g prime of x. That's what they're asking for, and that's one of my other properties, right? It's the derivative of a difference is the difference of the derivatives, and they asked me for x equals 1. So I need to look at this row and say f prime at 1 minus 2 times g prime of 1, and then just go to the table and figure that out. F prime of 1 is pi. G prime of 1 is negative 1. So this is pi plus 2. Leave an exact answer. If you're going to round, you have to write 3 places past the decimal. So just might as well leave it exact. The next one is the product rule. So the trap in this is to just find f prime at 4, because this is a 4 here, f prime at 4 and multiply it times g prime at 4. No, 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 no. Don't do that. To take the derivative of a product, you must use the product rule. The product rule never changes, though. The product rule is the first function times the derivative of the second plus the second function times the derivative of the first. And again, this is just filling in values then. Reading this line of the table. So what is this? 18 minus 10 thirds. So what is 18 times 3? If it is 54 minus 10, so that's 44 over 3. Again, here's another trap. And this is where you get no follow-through points. If you think to take the derivative of a quotient, what am I at here? X equals what? 4 again. That you just take f prime of 4 and divide it by g prime of 4, you are giving away every single point available for this on an assessment. No, no, no. The derivative of a quotient never changes. It is itself a quotient, but it is the bottom, no calculus, squared. And it is the bottom function times the derivative of the top minus the top function, high, multiplied times the derivative of the bottom, d-ho. And then I'm just going to my table, looking at, again at the row with 4, and I'm filling in values. Notice it's, right, there's my -5 times 2/3. My 6 times my 3. All over 2/3 squared, which is 4/9. You're going to have to clean this up a little bit. I have -10/3 in the numerator, minus 18, which again is 54/3, all over 4/9, which is the same as multiplying times 9/4. Right? Division is the same as multiplication by the reciprocal. So what do I get here? This 3 goes into that 9 3 times. So what do I have? -64. I guess I don't want to do that. -64/3 times 9/4. Sorry, I shouldn't have canceled that out yet. So is that -48? Check my mental math on that. I think that's what I've got down. All this nonsense is worth 1 point maximum. There's where most of your points are. Did you do the quotient rule? All right, I'm going to erase all of that to give myself some room to do the rest of it. Most common mistake with letter D is to say that's f prime of g of 1, which means you forgot to spit. The chain rule is a product, and you must multiply by the derivative of the inside. So what is g of 1? G of 1 is 4. So this is actually f prime of g of 1, which is 4, times g prime of 1. So f prime of 4 is -5. G prime of 4 is -1. So that's 5. Right? So trap, just multiplying the derivatives. Trap, just making a ratio of the derivatives. Trap, forgetting to spit. I'm going to do E up here. E, notice I wrote quotient rule or chain rule. Especially with a numerator that is a constant, I think I probably will say 1 over g of x is the same thing as g of x all to the -1. The trap in this one is once again to say, oh, this is just 1 over the derivative of g prime. That's one trap. No, no, no. The other trap is to say, oh, I just take a ratio of the derivative of the numerator to the denominator, and the derivative of the numerator is 0 to say this whole thing is 0. Oh my gosh, stop. If you see a quotient, you must either use the quotient rule or unquotient it and create yourself a chain rule problem. So if I want to take the derivative of this chain rule, I'll do it both ways. So I'm going to bring the -1 down, copy over the middle. And by the way, what is the number they're asking me to do this at? 4. And spit out the derivative of the middle. So what do I get? -1. Oops, sorry. I forgot to subtract 1 from the exponent. -1 minus 1 is -2. So this is -1 over g of 4 squared times g prime of 4, which is 3. So that's -1 over g of 4 was 2/3, and squared is 4/9, times 3. So that's -3 times 9 over 4, -27 over 4. Let's say I use the quotient rule. The quotient rule is the bottom squared, check. Then it is the bottom, g of 4, times the derivative of the top, which is 0, which means that whole side is going to go away, minus the top times the derivative of the bottom. So that's -3 over 2/3 squared, which is -27 over 4. So I got the same thing both ways. All right, again, I'm going to erase all this to give myself some room to do the last one. The last one's a little bit of a bear. I'm going to have to do the chain rule. I'm going to have to do some derivative of a difference is a difference of the derivative, and I've got more chain rule. So the first thing I'm going to do is rewrite this. This is f of x minus g of x squared all to the 1/2, for gosh sakes. So what do I have to do first? Bring this 1/2 down in front. Copy over the middle, spit out the derivative of the middle. Subtract 1 from the exponent. So what is this piece? The first piece is just 1 over 2 times the square root of what? F of, what number are they asking me for? 4. F of 4 is 6 minus g of 4, which is 2/3 squared, minus 4/9. Check, check, check. Times the derivative of the inside. Well, the derivative of f of x is just f prime at the number they've asked me to, minus the derivative of g of x squared. Chain rule, bring that 2 down, copy over the middle, subtract 1 from the exponent, that's just to the first, spit out the derivative of the middle. So what do I have in my numerator? f prime of 4 is -5 minus 2 times g of 4 and g of 4 is what? 2/3, so that's going to be 4/3, right? 2/3 times 2 is 4/3, but that's times g prime of 4, and g prime of 4 is 3. Well, that's kind of nice because that goes away, right? All over this nonsense. So what do I have up here? Because those 3's canceled out. So I have -9 over 6 minus 4 over 9. What the heck is this, right? So 9, 15. So what is that? 50 over 9, right? Because that's 54 over 9. Multiply that times 9 times 9. 54 over 9, right? Oh, well, goodness, what is that? That's -9 over 2 times the square root of 50 over the square root of 9, which is 3. So that's -9. Instead of having this divided by 3, I'm going to multiply by that by 3. That's -27 over 2 root 50. I probably could do even more with that because I can pull out a, right? I can pull a 5 out of that. That's a 10, blah, blah, blah. I'm over this though. Right? Again, most of your points is going to come here as you do all that together. At most, this is 1 point yielded if you don't have time. All right, so the next part of this content video is to show you the pages of the little review book. And in our live session, we'll do some more review problems together. Remember, though, a bunch of the review sheets are, including this one, are linked on our Canvas page under the Thursday, Friday, in the Thursday, Friday box. All right, little book time. Derivatives volume 2, right? You already have a derivatives volume 1. It's time for derivatives volume 2. Chain rule. So don't forget, you want to have on here, you want to have like your definition. And I don't mean definition in words, right? I mean the derivative of a composition is the derivative of the outside, don't touch the middle, times the derivative of the inside. You also, under chain rule, want to have that, look back at the content videos if you don't remember the chain rule this way. Right? It's a product of two derivatives. If I want dy dx, and I could use whatever letters I want as long as you see the chain be the chain, right? Also, you have your formula for parametrically defined functions, which really come from this step. Dy dt, which is right here, divided by dx dt, right? Multiplication. Multiplication is the same as division by the reciprocal. Division is the same as multiplication by the reciprocal. So this is for the case when you've got, right? You have, for example, x is equal to sine t Let's make it cosine t, so it's like the unit circle. And y is equal to sine t. You can find dx dt and dy dt, but if I want dy dx, I can just make a ratio of the derivatives. Implicit differentiation. When x's and y's are mixed up together, you must use the chain rule. The chain rule for sure. And then remember, some problems also had the product rule in it. For example, if I just give you x squared plus y squared is equal to 16, you just need to use the chain rule on the y part. But if I gave you x squared minus xy plus y squared is equal to 16, you have to use the chain rule here on this y. You have to use the chain rule there on that y, but you also have to use the product rule because x and y are multiplied together. Don't forget that for implicit differentiation, one of the applications there is to use implicit to find horizontal and vertical tangents. Refer back to that handout. That I did with you in the content video called Graphical Implicit Differentiation. Also remember that you might need to find the second derivative, which is implicitly, but don't forget that when you do that, you need to replace y prime in your second derivative. Inverse trig rules, there are 6 of them. Six of them, right? And just do some practice problems. Same with the exponential and log rules, right? Derivatives in any, you really only have to know that if y is equal to any number raised to a variable, the derivative is the same thing times pay the price. Okay, practice. Don't forget here, though, that I taught you a process, not a rule. This is a rule, 6 trig rules, exponential and log rules. I gave you a process of how to take the derivative of a function raised to a function. And that was called logarithmic differentiation. Oh, I forgot I had a whole page for logarithmic differentiation because sometimes those problems are long. Here's the page for the derivative of the inverse. This year, we will not put on the Unit B test, Unit 3B test, but it is tested on the AP exam. So it's good to have it in your little book. You might want to do an example of AP style, which is like that table style. Do an AP style example and a traditional one from maybe like that handout. And then this back is blank. So you can put whatever you like on it. You can put an inspirational message to yourself, right? Go dog. right? You got this test, right? Calculus ain't no thing. Stuff like that, right? You can put that on the back. Um, or not. But certainly please do put your name on it. And you'll be making a little short video of your review book so I can get a little, have a little fun watching you and listening to you. Please, no silent movies. All right. I will see you soon. Bye.